us by Mr. Ramprakash Ramamoorthy. He is from Zoho. He has been leading the AI efforts at Zoho Corporation, an alumnus of Shastra University, kickstarted the AI effort within the company and built the company's AI platform, Christian Zia, from scratch. Today, Zia powers AI features across Zoho Corp's suite of products and handles a ballpark 70 million requests a day. A passionate leader with a level-headed approach to emerging technology and frequent talking at a lot of technology conferences and events. So, welcome Mr. Ramprakash. He's going to speak on AI from labs to production, challenges and learning.
So I'm the last man standing between your lunch. So I hope to make this talk interesting, right? So let me just dive straight into the talk. So I work for Zoho. Zoho is a 7,000 people company in Chennai. We do a lot of B2B apps, right from network management to office management to productivity and all that. So in Zoho, I represent a group called Zoho Labs. So Zoho works this way. Zoho has about 50 product teams, and these product teams probably share a common set of problems. So we have a central group called Zoho Labs, which work on a lot of advanced technologies. So we are one of the most active contributors to PGSQL. We have a team that works on hardware acceleration using GPUs and FPGAs. And then there is a team that works on AI. So I lead the team over there. So we have almost 3 divisions over there. One is the statistical ML team, one is the deep learning for text team, and the other is the deep learning for computer vision team. So this is the high-level organizational structure of what we have done. So we actually set up Zoho Labs in about 2014, and that is when we started the AI efforts in there. And so today my story is about how we the process of us pushing AI to production, building a viable business model around it, what were the challenges we faced after deployment and all that. So typically there is a lot of advice on the internet about how to use the algorithms, how to tune them and all that, but productionizing them and making it a viable business is what I wanted to highlight in this talk. So AI per se is still very snake oilish, right? There is a lot of hype around it, but the actual monetary value of this technology is still, it is still evolving. There are a lot of high promises, high stakes, but is it really delivering to that kind of hype around it? Right? So we operate in the B2B space. So typically you look at AI, it is about recommending your next movie, it is about recommending your next product, or increasing the click-through rate for a marketing article. But the B2B world is like very different, right? So in B2B you have customers coming in, their data should not leave your data center, it should be very protected. So you look at AI in general, right? So there are a lot of algorithms, most of which are open. And then there are a lot of frameworks which have implementations of these algorithms, most of which are open, right? So in the B2C world, you have a lot of data advantage. For example, let's say there is e-commerce company A and then there is a search company B, right? So search company B knows more about you than the e-commerce company A, so which means it has the data advantage over the company A, right? But in the B2B world, there is no obvious advantage between two companies because most of the frameworks are open, most of the, there's no secret sauce you add, right? So it is like the petroleum business. The government is going to set the price. There's not much of differentiation in your products. You can just say, okay, come and fill in this petrol bunk and you feel happy, you feel satisfied, cook in this gas, serve love. So, but it is really not a viable business model where there is very little to differentiate between your competitor and you. Right? So we face a lot of challenges in actually making our users get to use the AI features. So I'm going to talk about all that. And the way I introduce Zoho Labs, it should sound very good on paper, right? Yes, you have a central team that is working on all difficult technologies, and then there are 50 eager product teams that come and get your solution and thank you for that. But the real world is not that way. It is weighed on the hype behind the technology. Now, for instance, take our PG team, right? So our PGSQL team. Nobody really wants to get down to the database, look at the threads, and get down to the operating system level, and it is not very cool, right? So our PG team is able to sell, basically we are selling technology to engineers inside our company, which is as good as selling ice to Eskimos. And you look at AI, it is the hottest thing in the world, and every flamboyant developer in every product team wants to get their hands wet. You are a central team, why do I come and use? I'm going to do it myself. Right? So it is very difficult to convince them about the value add as a central team. I thought it was specific to our organization, but I talked to a lot of people and I identify that this is there in every organization. So the way to go is, we are taking a hybrid approach. One, there is a central team which is kind of granddaddying the technologies, and then there are small implementation teams across the product teams, and it is the way in other organizations too. For example, Uber has a platform called Michelangelo, and each of its own team have their own set of data scientists who build their implementation on top of the central platform. So we have finally decided that the only viable way to go about taking this to production is to have a hybrid model where there is a central team and there are a lot of implementation team which get the help of the central teams and get it through their products. So that is what we are operating. And so to look at the challenges we faced while pushing AI to production, there had to be some level of looking at the AI algorithms, right? So typically you look at it this way, okay, there are classification algorithms, there are recommendation algorithms, there are regression algorithms, and then there are a set of deep learning algorithms. But we built a lot of tooling, we built a lot of ways in which we interact with these algorithms for which the classification, regression, recommendation approach was not helping. So interestingly, this is a very good book called The Master Algorithm by Pedro Domingos. Maybe you might want to, I think it is hands down the best practical AI book that is on the market today, right? So this book takes an approach where you divide your algorithms into 5 clans, and essentially all these clans have similarities so that you can build your toolings for each of the clans separately. And the last part of my talk will cover actually what are the kind of toolings we build around it. So maybe you will get a clear picture then, but then I will introduce you to the 5 clans. So the first ones are the ones using symbolism. The example could be a linear regression, where you take your cross-validation scores. You predict something, you do the inverse square of it, and you identify its accuracy. Right? So all your linear regression type algorithms come under the symbolism category. The next clan is connectionist, which is basically neural networks, where it is engineered on the way the human nervous system works, and this is making a lot of strides these days. Leave alone neural networks, there is something called HTMs, which is called hierarchical temporal memories. It is actually based on the synapses which connect your neurons, right? And this model, the world is actually not getting into deep learning because of the computational demands it has. So you need a GPU to run it, and it is very expensive, where your business model is when you offer on wafer thin margins, right? All B2B companies, all SaaS businesses run on wafer thin margins, and then there's only way. So something has a 75% accurate. To make it 78%, you will have to spend $10,000 on a GPU, which is not really viable. So the world is moving towards technologies like HTM, which are similarly inspired by the working of the human brain, but slightly modified so that it runs better, runs with lower amount of data and all that. So this is about connectionists. The next thing is evolutionary. So the idea behind evolutionary is the genetic algorithms, where you generate a candidate set and then you apply some fitness function over it and see how well the generated candidate sets perform and take the best set of. This is mostly used in, I think you should have heard about GANs, right? Or anything that is very creative, some artistic form of creating AI, all those come under evolutionaries. And then there is Bayesian, the famous probability element. There's a deep level of research going inside probability, and it has been there from start, and it is also heavily linked to statistics. And the final clan is analyzers. This is something which we use heavily in production. Actually, I mean, we didn't have a bias when we started, but if you look at the general theory of this is, you project it to a higher dimension. So think of something like SVM here, right? So you have some 3 kg balls and 5 kg balls. You basically throw it up into another dimension, right? And draw a straight line. You would be segregating the 3 kg and 5 kg balls, right? So the 3 kg balls would be higher and the 5 kg balls would be lower. So basically, the whole idea of this is you project it to some other dimension where you will get a lot of intelligent ideas. So even Fourier transforms come under to this. So you project it to some other domain, and then you are able to get the better of it, and that's how these algorithms work, right? So now have these 5 clans. Just think about these 5 clans. We'll revisit it later how building toolings around this was helpful. So I will actually walk you through our story. Back in 2011, when I graduated out of college, so I went to Zoho. I was a very young kid over there, and that time the world had just finished the hype of Web 2.0, right? Moving from JavaScript to Ajax, moving from SOAP to REST. It was all cool, and then it was 2011, people started talking about Android apps, right? Smartphones, and it was that time of the evolution phase where the smartphone bug had hit the developer community. And I went into the company saying I wanted to become an Android developer, and they said, okay, you first do this project, then you can move to becoming an Android or an iOS developer. So the project assigned to me was, we had a lot of support desk solutions where customers or in-house employees ask questions to a central team. It is a ticketing system basically. So we'll have to identify if that person is angry or happy about it. So back then it was not, we didn't realize it was called sentiment analysis. We are trying to predict the mood of the customer. We went about it that way. So we said, okay, we will collect a bag of good words and then we'll collect a bag of bad words. We will count, and if it is good, we will say the customer is happy. If it is bad, we will say the customer is sad. And interestingly, there came in solutions like, how on earth will someone buy this product? It had nothing negative about it, and we're not able to capture. And then some more digging into the internet, there were tools like, it was also in 2011, the big data wave was catching up, where all the map reduce, and you don't move your data to the processor, instead you move your processor to the data. Funda was quite catching up, and that is when we looked at Apache Mahout. Mahout had some, some implementations of Bayesian algorithms, so we put it into use. And then, okay, so we went about it, okay, there are something called data sets, we'll go get some data sets. We got some IMDb data sets, we got some Amazon customer review data sets, we trained it, we just tested it, and everything went well, unless and until we moved it to production, right? Because all these Amazon product review data sets had a lot of cuss words, right? So it was a very colloquial tone. It said, okay, this product sucks, your product is shit, this movie is horrible, okay? But a typical B2B email lands this way. Dear so-and-so, your product sucks, thank you, with warm regards, so-and-so. Please do not print this email, please take care of the environment, right? So which means you had a very different data set, and okay, in 2018, this looks so naive, okay, how can you miss something there? But in 2011, when we were taking baby steps towards it, it was it took time for us to comprehend what was happening. And so after that, I moved to a different team. I was working on log search. It was a very interesting thing. And then came 2014, where we set up a division called labs, and we thought we'll go about the problem which we worked in 2011, because more number of people have started talking about it, and we expect the curve to, the hype to grow. That is when all these machine learning, artificial intelligence terms like these started flocking the internet. So we started it off again. Once again, it was just me. I was all excited about the math. Hey, look, how cool is that gradient descent working? How do I tweak this learning parameter so that I hit the local minima I hit the global minima very fast? It was all so cool. We got very excited about the math, and we started expanding the team. We worked on R. We just calculated the algorithms on paper, and then we looked up to Andrew NG scores. We did everything. We're all ready. We announced, hey, look, we are ready. All product teams, please come to us for our AI solutions. There were a couple of teams that were interested. And then we realized, okay, we are not a startup that is going to do any AI problem that comes to your way. We are a company with products that are on average 8 years old. So which means you got to retrofit machine learning into it and see how it works. And the data was a very big challenge. So you had to go ask the product teams first to generate these data points, and then you do some analysis on it so that you give the results. And it was quite a difficult process, because it is a SaaS product. So basically you ask them to log the data points, you get the data points, you find out that you can't do anything with it. So it was quite difficult, a challenge scrambling the data pipeline. So where do you store, how long do you store? And then there are also legal complications that come in, especially with, so we were working with a EHR product, and we had to wade through all the HIPAA complexity. So we're not able to move the data, or we're not able to see the data, even though the data was anonymized and all that. We ran into a lot of challenges, but then we set up the data pipeline, things were set. Next interesting thing was the tuning parameters. So we have decided on an algorithm for a particular problem, but what kind of tuning parameters do you tweak for getting it right to every customer it is served, right? So we had to wade through those difficulties. And like I said, plumbing data pipelines, so let's say there is a team that has an email product, there is a team that has a support desk product. We're trying to do sentiment analysis on both of them, but the support desk product, typically you end up in a support desk because you're very angry, right? Nobody writes appreciation email to support email, right? So, but in the case of email, it is totally different. So, we had to strike a balance between two teams' data set and also the domain. So, let's say somebody says, okay, my flight pushed back on time. While pushed back could mean something negative in another domain, but in this domain it could be right. So, we had to wade through all those challenges. We had to make sure we set. So, I have slides talking about how we did all that, but yeah, we had this setup. And then we moved to production. So, that is going to be the rest of my talk, how we survived in production. So, like I said, there is definitely a need for value proposition. Unlike a B2C setup where, let's say, Facebook is recommending a friend to me, it need not explain why it recommended that particular person to me. If I'm not going to like it, I'm just going to skip. But that is not the case with B2B setup. I say I'm going to, you got to replace this sensor, but if you don't tell me why, I'm not going to do it. Or you think there is some predictive maintenance that is coming on, or you think there is an anomaly. Unless and until you tell him why, the user is not going to bother using your AI. It was a very difficult problem to crack. So we pushed it with lots of effort, lots of sleepless night, we got it to the customer. But the usage chart never picked up. There is not a single question, there is not a single compliment, there is not a single complaint about it in the forums. And we're just wondering why. So we looked at it, we had technically moved from process automation to decision automation. Right? So AI is basically deciding something on behalf of the user, which was a black box to the end user. And the way the B2B world operates is somebody who's using your product has a strict hierarchy. He really does not have a free hand in moving things he wants to. So unless and until there is solid evidence to do something through which he can approach his manager, there's no way he's going to do it. So that is when we thought of bringing in model explainers. So model explainers, this trend is catching up very fast in 2018. We did it back in 2016 and we pushed it. We also have an open source version of model explainers. So this is the paper which we got inspired from. This is one of the very first papers that started talking about interpretability of models. Right? So for the technically inclined, this is basically what we did. I will get through the details. So the idea is we were trying to predict a locally faithful explanation for a given model. Meaning, let's say this Hilton is our office, right? You're trying to buy a home somewhere around Hilton, right? There are two cases here. One is a global explainer case, two is a local explainer case, right? So basically, let's say you have these variables. You have your size in square feet, you have your age of the property, you have your distance from Hilton. You have three variables, right? And another variable which probably says is ultra luxury, yes or no. It's a Boolean variable. So now you have a global explainer. A global explainer would typically say your price in lakhs is directly proportional to the size in square feet. It is obvious, right? So that is what a global explainer would tell you. But let's say there are two cases where there's one case where you're buying an ultra luxury home, right? But it is still far off from Hilton and it is small in size. Okay? But here the decision maker for that particular event is the ultra luxury column. Right? So you will have to take your decision based on each and every query. We call it local faithfulness. Your decision, your explanation should be based on your query and not based on your global model. Right? So here whatever we did was we had some model, we had a tree-based model in production and we looked at the L1 and L2 norms of it, identifying who is contributing to the actual result, and then we started eliminating the lowest contributing guys, and then we came up to a couple of features which actually we think would contribute, and interestingly our usage shot up and we are also able to debug our models a lot better. So we had a lot of intuition on how the model is taking decisions. There was a case, I know it is still there was a case with an intern's project where a patient ID was being heavily correlated to his chance of getting the disease. We were able to eliminate all such things which a naive data scientist would actually ignore or would actually miss it. And this was, and we are also able to select algorithms based on the decisions that came out through this. Talked about local and global. So we have also open sourced this. Maybe you guys want to take a look. There are a lot of stars that are coming on to this GitHub project. So we have built our framework on top of Apache Spark since we are primarily a Java company. All our ML stack is based on top of Apache Spark, and all our DL stack is based on TensorFlow and Keras. So this is basically fits into the Apache Spark setup. So if you're running something on JVM, then maybe please look at this explainer. So the next thing, okay, we got it shipped. People started using it after explanations coming in. There was a lot of traction. The next thing that the world is, we are also getting started on this. We have not gone much depth into it. The next thing is causal interference and counterfactual reasoning. So basically, a person is getting his loan rejected. You tell him your loan is rejected. There is an explanation clause that kicks in and says, okay, hey, your loan is rejected on your salary. Right? It is helpful, but it is still not helpful. But this counterfactual reasoning algorithms come in and say, hey, if your salary was 10,000 rupees higher, you would have got this loan. Interesting, right? So the whole idea is you build a very complex machine learning classifier out there, and you augment it with a simple set of rules that can help explain the machine learning model's decision. So that is the kind of big picture about this. So your models could be complex, but build a small layer of explanation around it. So we also did this. We have actually a deep learning based error correction system, grammar error correction system. So interestingly, the way it works is you have two corpuses. One is some novel corpus where you have all good English written properly. Two is you have a wrong sentence, you have a right sentence. So you run a deep learning model to learn about this. So the next time you give it a sentence with a mistake, it actually corrects it. And then we built a small ML based model around it to explain what is the correction. So is it a misplaced noun, or is it a spelling mistake, is it a singular plural mistake? And it actually worked. People were convinced that it is working. So basically you have a complex model and a simple model to explain the complex model. So Site 24/7 is a networking product of ours. So the kind of use cases we were looking at it is, we had a single univariate anomaly detection, and then we had a multivariate anomaly detection where it could not just be, let's say you have a CPU, RAM and free disk space. It is basically a monitoring solution, something that monitors your health of your servers and all that. You have CPU, RAM and free disk space. At some point of time, it could just be your RAM causing the anomaly. At some point of time, everything could be at a 70% threshold, which could more likely, a combinatorial effect could more likely be contributing to an anomaly. So we had a multivariate anomaly there. And then the most interestingly used feature is all these alerts. So you have all these, especially in IT, OM, IT operations management products, you have a lot of alerts coming in because there were human set thresholds, right? So but the guy at the receiving end of the alerts always applies a human judgment to it. Okay, he knows it is going to be a false alarm and he's not going to respond to it. So we had to automate that process of manual thresholding. We were continuously monitoring the systems and identifying what is normal at a given point of time. If something deviates beyond the normal, then you alert it and you also tell him the expected count. Hey, at this point of time, this was supposed to be expected, but I'm getting this. And we were able to identify all the frequent patterns. So basically, someone is logging into a firewall and then logging into a machine and then changing a file, which is perfectly normal. So you have 3 alerts coming to it. We group this into a single alert. And then there is some rare pattern. Somebody hasn't logged into a firewall and is just logging into a machine and changing some file, which means there is a problem. It is one of the rare patterns or one of the unseen patterns in your setup. So we started pushing out, and we have got some really active user base in this kind of setup. So now coming to a lot of tooling we built around AI. The first thing we did was we built a data repository. We all have source code repositories, but data repository is where when we have multiple engineers, multiple teams working on the same set of data, you should know who is going to modify what. Basically, there's one guy who does, there's a data set A, there's one guy who does a dash, and then he's going to go down that path. There's another team which does a double dash, and he's going to go down that path. And each of the corrections could be specific to that particular team, and if you're going to mix it, you're going to mess up. Unlike the source code where at some point you try to integrate it into the master, here we don't know how it is going, but we have built a simple GitHub-like data repository, and trust me, it has improved the productivity of our data scientists a notch. And we have started relying on optimization techniques, so Bayesian optimization techniques, where we try and identify all the parameters you use to tune an algorithm. Let's say you're taking a tree-based algorithm. You have multiple parameters, your depth of the trees, your number of trees in your forest, your learning rate, your alpha, and so many parameters. So basically a developer is going to do something, he would just stick on to the default set of parameters which your framework is giving you. He's not going to go change it. In case he's going to change it, you might end up overfitting or underfitting your application. So we have any model that goes into production passes through an optimization algorithm which naturally sets all the variables so that your cross-validation accuracy is maximum. Right? So we have done that. And we are also tracking parameters changes which goes through reviews like your source code. So any parameter or any data thing you change is also tracked and it is also being reviewed the same way your source code is being reviewed. So now we have a separate process for source code review and separate process for the dataset review. This is the most interesting problem we faced. We call it, it is called concept drift. Not that we call it, it is called concept drift. The whole idea is, let's say you create a model in 2011 where the average BMI was 24. But come to 2018, lots of fast food and all that, let's say your BMI actually shot up. Or think of something like you created a model here in Nikatatangal where the price in square feet was somewhere around 6,000. But now Hilton has come up, Metro Rail has come up, now price is somewhere around 13,000, right? So now think of it, you are in a SaaS solution where there are about 2,000 organizations that are using your product. Now how do you sit in your office and identify whose model has undergone concept drift? Your user is never going to report at some point of time if this AI, it is not a very mission critical feature. I would also say that. It is not a very, AI is not very, okay, without AI I can't work. We still haven't moved to that kind of setup in the B2B world. If it is going to give wrong answers, he's going to shun it, he's never going to use it again. So now how do we not let that happen? So we had something called concept drift where we identify, we periodically monitor our models to identify their cross-validation score. It is most probably done by active learning. So basically your user can flag, we typically know this model is 75% accurate. If it continues to be 75% accurate, we'll be happy. If it drops to 65, then something is wrong. If it goes to 85, maybe we are overfitting, you need to have a tab on it. This is the kind of status. So the first thing is identifying concept drift. Let's say the price here has gone up by 5,000 rupees per square feet than when your model was created. So you have identified that. The next thing you do is you will have to adopt that. So how do you adopt that? You might not have enough data to retrain your whole model because retraining is very costly. So instead, you just append 5,000 to all your input queries or you just subtract 5,000 to all your input queries so that you stick to the original model, right? So that is identifying concept drift and fixing concept drift. There are many ways in which you can do it. One is using a supervised active learning setup. The other is, let's say you're doing a ham spam classification and probably 5 years back they were doing ham spam by an African king who is donating all his money to you. But today maybe they are spamming you with an OTP. The pattern has totally changed, right? And there could also be hidden feedback loops, meaning they know that you are using this pattern to capture his spam. So he might actually change his spamming pattern to wade through that, right? So instead, how you can do this is without, in an unsupervised way, you typically know 25% of your emails are going to be spam. And all of a sudden, only 10% of your emails are spam. So you just look at your results, you just look at your classification results, you do not look at the customer's data, you just look at the classification result and build a simple linear model around it. You will know something has changed and you identify there is a concept drift. Now, maybe talk to the customer, talk to him about what is changing and you should be able to fix concept drift. Right? You will have to do your adaptation to it. Like I said, you subtract 5,000 from your current price and you look at the decisions. And interestingly, we also did A/B testing of models because I'll tell you an example. So we were actually deploying a deep learning explanation model where, so the point is you might not be able to test all possible cases of how your model can be used, right? So there were a couple of interesting examples. One thing that is at the top of my mind was we were trying to, generate captions for images so that you make those images searchable. So the first, I presented a photo of from my last vacation where it was a swimming pool view from the balcony. It said, oh wow, what a great view. Right? Okay, this is working well. And then I showed a picture of a house with fire burning all over it. And it said, wow, that must be a glorious scene. Like, you look at it, because probably my training set was biased. I fed in more positive labels, more happy labels, and it was all bright, it was all yellow, it was all burning, and it thought it was a very happy thing to do. So we started doing A/B tests on models. We deployed some 5 variants of the same model at a time. We got feedback from the users, and then we made one mainstream. This is typically done in web pages, but I don't think anybody is doing it for statistical models. So that is what we tried to do. And yeah, this is a very classic problem. How do you not make the model overfit? It should be generic, generalization. Basically, your neural network is very good in, it is like a state board student, right? Whatever it sees, it can know, but anything outside, it stutters. It's going to throw you garbage. So how do you take that balance, was the question? Now, coming to setting expectations to the customers and selling. This was another interesting challenge, something that was not discussed elsewhere when we started off. I don't know if it is being discussed now, but we had a... So, most of the AI commercials look at it this way. Dear radiologist, I'm going to replace you. Dear Uber driver, I'm going to replace you. See, that is not going to work. 2015, I think 2015, yeah. 2015, Elon Musk said, I thought in 3 years we are going to have self-driving cars, but I'm now reducing it to 2 years. 2017, 2018, we still don't have self-driving cars, even in regulated markets like Germany or in the US, right? 1986, US Department had OCR, US Postal Department had OCR, right? But if we were expecting OCR to deliver 100%, we would still be expecting US Department's OCR, right? So we're just going to tell them, hey, AI can augment a driver to drive safely. It can detect fatigue, it can detect sudden acceleration, sudden deceleration. AI can augment a radiologist. It can tell him that, okay, this person has more chance of getting a diabetic retinopathy than, okay, if you probably go take a scan, let's say you take a scan for 10,000, only 2,000 is going to that human element, right? Remaining 8,000 is going to that actual machine, which is imported, which we don't make in India, right? So instead, AI could come in and augment the machine where you replace that big camera with too many small cameras and try to reconstruct and all that, but this human element is inevitable. There's no way AI is going to replace humans, it's only going to augment them. So your sales pitch has to be that way. Go tell them, hey, I'm not going to replace you. I'm just going to help you do better. I'm going to make you productive, and it sells. And right, you don't go about, see, B2B customer is not at all worried about what big technology you use. He just says, it should work for me, right? You don't go telling, hey, I am using AI. You use if condition, I'm least bothered, but please make it work. Debugging AI is a real challenge, right? All of a sudden, you have an angry customer writing to you saying, hey, how do I turn off this, please? This sucks, right? Now, you have legal regulations, you have GDPR, you can no way go look into his data set. Even if you get his permission, he's only going to share that particular email which didn't work. Now, how do you go about fixing it? So, the way we handled it is very subtle. We did not show it on the face, okay? We just had AI suggestions scrolling down. So that is how we released, and eventually once they got confident, we pushed it on their face. But the first move was not on their face saying, hey, this is it. Hey, this could be this, you might want to check. There's a subtle notification which sent, and we tracked that based on the usage, we got it out. Right? And this is something which is in your control. You have, so this is a translation from Turkish to English. You see how gender biased it is. So generally, everybody talks about bias in AI, democratizing AI. There are cases where, when you say a CEO, it is always a white male, right? And there are cases where soap dispensers do not dispense soap for colored skins. It only dispenses for white. So it is all the inherent bias that is built into us, which propagates to the models, because it is we who create these models. It is not, I don't know who named it intelligent, but it is we who are doing it. It is another form of programming out of data. That's it. So we had to wade through such. So in the real case, so most of our servers are Linux. We still have a few Windows machines running. Our data set was always biased that if it is a problem, it is a Windows machine. This is the equivalent. So 4 or 5 years back, when you go to all open source conferences, a lot of open source conferences, when you go there, when the projector is not working, they said, okay, Windows, it is the problem, right? So that bias kind of propagates into it, and this is something which can happen at your customer's end, right? There's no way you can go about fixing it. There's a huge way to go, right? Okay, beeping. So right, the road ahead. Product management has changed forever. 1 year back, product management was all about writing reusable code, planning your roadmap, fixing bugs, doing agile stand-up meetings and all that. But today, the number one duty of product management is to look at what all data points your product is going to generate, right? So that you can do some analysis on it and you can differentiate from your competitor. Learning on the edge is going to become very important. Deep learning is not selling because it needs GPUs. So basically, you need AI that sits inside your surveillance camera and then sends data. Instead of sending all data to a big server, processing it and getting the results. That's not going to work. You need AI, it's like the low energy tech. You need AI that works on low data and low processing power. Bias has to be removed. Obviously, it is on the hands of your data scientists so that they don't propagate the bias to the models. I'm almost done, please. And the next thing is decentralized AI. AI data poisoning has become a thing. Basically, let's say you're training a self-driving car, suddenly someone waves a yellow flag at it, it's going to stop. There is no way you can decipher it, but there could be inherent problems with when the data is stored in a single place and all that, so you decentralized it, blockchain tech is catching up. So making your models, training your models on top of decentralized AI is the next big thing. A lot of legal challenges, there is GDPR. Now explanations are going to be mandated by regulations like GDPR where you're making an algorithmic decision, you'll have to support why it comes in. So the winning AI companies are definitely going to do explanations and counterfactual reasoning. There's no escaping from it. AI security, like I said, data poisoning is a term that is catching up very fast. You should know how, or there should not be any bias. You should not, especially in countries, authoritarian countries like China, where surveillance is very common, they're trying to predict crimes even before they happen, right? So based on what you do, it could have a serious religious bias or it could have a serious gender bias on you, but we'll have to make sure that does not happen. There's a long way to go. Right, thank you. Thank you.